Welcome to a sim code. Want to see how much fun coding can actually be? Hit subscribe and let me show you how we can turn those lines of code into something awesome and maybe add a little spark while we're at it. Selection sort is a simple and intuitive sorting algorithm that works by repeatedly selecting the smallest or largest, depending on the sorting order, element from the unsorted portion of the array and swapping it with the first unsorted element. The process is repeated until the entire array is sorted. Specifically, in each iteration, the algorithm scans the unsorted section of the array, finds the smallest element, and places it in the correct position in the sorted section of the array. Though easy to understand and implement, its time complexity is O, not superscript 2, which makes it inefficient for large datasets compared to more advanced algorithms like quicksort or merge sort. Despite this, it can be useful for small arrays or educational purposes to demonstrate the basic concept of sorting. Function to perform selection sort. Selection sort is a simple comparison-based sorting algorithm. It repeatedly selects the smallest or largest, depending on sorting order, element from the unsorted part of the list and swaps it with the first unsorted element. ARR is the array we want to sort, and N is the number of elements in the array. Now, let's talk about how the algorithm works. Outer loop, we will iterate over the entire array from index 0 to n1. At each step, we assume that the current position I is the position where the smallest element from the unsorted part of the array will go. Loop through the array from the first to the second last element. I represents the current index of the unsorted portion of the array. We start by assuming that the smallest element in the unsorted part is at I. We will compare the current element with the rest of the unsorted array to find the actual smallest element. Assume the element at index I is the smallest. Inner loop. Now, we will check the unsorted part of the array. This loop starts from the next element, I plus 1, and searches for the minimum element. In the remaining part of the array, loop through elements from I plus 1 to the end of the array. Compare the element at j with the element at min index. If ARR j is smaller, we have found a new minimum. If element at j is smaller than element at min index, update min index to the new smaller element's index. After the inner loop finishes, we have found the smallest element in the unsorted part of the array, and we swap it with the element at the current position I. If min index is different from I, we swap the elements. if the smallest element isn't already at the correct position. Swap ARR, I, and ARR, min index. Store the value of ARR, I, in a temporary variable. Place the smallest element at the current position. Put the previous element at the position of the smallest element. After this step, the smallest element has been placed in the correct position at index I. The array portion from I onwards is now considered sorted. Function to print the array elements. ARR is the array and size is the number of elements in the array. Print each element of the array to show the sorted result. Loop through each element of the array. Print the current element in the array. Main function where we test the selection sort function. Let's define an array of integers to be sorted. Define an array with elements to be sorted. Get the size of the array. Calculate the number of elements in the array. Before sorting, let's print the original array. Print the original array to see it before sorting. Call the selection sort function to sort the array. Sort the array using the selection sort algorithm. After sorting, let's print the sorted array. Print the sorted array after sorting. Return 0 to indicate successful execution. All right, guys. Now you have a full breakdown of how the selection sort algorithm works. It may not be the fastest algorithm out there, but it's definitely a good starting point for understanding basic sorting techniques. If you found this helpful, make sure to hit that like button, subscribe for more awesome coding tutorials, and leave any questions or thoughts in the comments below. Happy coding, and see you in the next video. Now run our code. I hope you had a blast. Don't forget to like and hit the subscribe button.